Okay, so let's talk about some. When we say random, let's talk about some practical ways to do that. In class we'll look at using a calculator to pick a random number, but one of the techniques is using a random digit table. Now, when I show you this, this is very old school. It's very back before we had calculators and computers that would do this sort of thing. They would actually publish books of these random digit tables, and you would pick a random digit table, and that would help you decide where to get your sample from and what random number to pick. But the characteristics of a random digit table is that each digit is likely to be anything from 0 to 9. So no rhyme or reason. High-powered computers went and figured it out, and we're just benefiting from this. Each digit is independent of each other. So here, for example, is a random digit table. It's got 3 rows in it. The blue is the 1, 2, 3. There's the 3 rows. Um, and when the way we use this, we can either read the numbers across. So I can either go 451, 850, or I could go the other direction across. That doesn't really matter. I can also go up and down with the digits. Or the other way is I can actually go diagonal with them, one way or the other. And we use the random digit table to help us take the bias out of our picking. I know it sounds silly, but hopefully at this point we've done that in class activity about samples. Um, okay, so just kind of get us on the same page here. So we've got a population of 20 people, and we're going to use a random digit table to pick 5 individuals. And those are going to be the 5 that I'm going to use for my sample. That'll determine what the 20 people are thinking on a particular topic. Yes, I understand 20 is not that big, but this is sort of how they do larger surveys on this smaller scale. So I'm going to go ahead and I'm going to read it across, and what I'm going to do is I'm going to look for 2-digit combinations. Now, why 2-digit combinations? Well, if I look at the largest number I have, the largest number is 20. It takes 2 digits to make 20. So 1 would be 0, 1, 2 would be 0, 2. There's two digit ways that I could write each of those numbers. Okay, so I'm going to group them up into 2-digit combinations. So 45 is not there's no one in the sample, in the population with a 45 sampling frame designation, so 45 doesn't get picked. 18 does. 18 would be Tracy. 5 would be Edward. 13 would be Matthew. 71 doesn't have anyone to correspond to, so I ignore it. Number 1 does, so that would be Aiden. I ignore 55. I ignore 80. And 15 would be Opus, would be the last person picked for this particular sample. Okay, so anyways, that's how you use a random digit table, is you follow it in that order. And again, I just showed you horizontally. If we did this vertically, we would have a different grouping. If I did it backwards versus diagonally, I might have a different grouping. Uh, anyway. Okay, let's talk about bias. Bias is, well, here's the definition of it. Is a systematic error in measuring the estimate. Now, it sounds like an error means somebody made a mistake. In statistics, we don't necessarily say it's a mistake or an error of that nature. We refer to when we show bias in data, we're favoring a particular outcome. Um, so it's anything that causes the data to not represent the population. It doesn't mean a mistake mathematically was made, but it means the method in which we collected the data affected the outcome. Okay. Now, before I get in and do this, I just want to mention that there's statistics is not a perfect science. Every time I teach this, students walk away thinking everything is evil and that there's no value or meaning anywhere in statistics. That's not actually true. But whenever we get information, we want to stop and think, well, what kind of bias could have impacted the data, and is that information significant enough that Maybe I want to throw out the entire conclusion, or maybe I want to listen even more to the conclusion and go, well, if there was bias and that was the conclusion they came up with, oh my, it's actually worse than we think it is. Um, Anyways, so sources of bias. These are anything that can cause the bias in the sample. And typically, if we have very biased data, then we can't really make a useful conclusion off of that. Okay, first type of bias would be voluntary response. These are when people get to choose to respond. Turns out if they're really excited about responding, that's because they have a very strong opinion. They're very passionate about something. Things like American Idol or other call-in shows where they ask people to give their opinion. These are people that are very passionate about that particular issue. So they usually either really, really agree with it or really, really detest it. So you usually don't get middle ground with these types of responses. You usually get the extreme ends. Okay, again with voluntary response, because we're going to look at different different categories of this. The key here is the person gets to pick whether or not they respond. Okay. Convenience sampling is another type of bias. This is when we ask people who are just easy to ask. Okay. Have you ever been to the mall? I haven't seen this lately, but back in the day, they used to have people that uh, would come up to you in the mall and they'd ask you for your opinion on a particular topic. They always made them young and pretty and professional looking, so you wouldn't be nervous to talk to them. Now, those individuals were trained, or not necessarily trained, but they were asked to go get 20 surveys. And they would go pick people who were easy to talk to. Like you wouldn't go talk to a mother that's got two screaming children. She's not going to talk to you. But if you saw some guy standing by himself, he'd be a little bit easier to approach. Another illustration of this would be surveys left on restaurant tables. You know, those little forms that people fill out. It's very easy to, you're bored and you're like, I'm eating breadsticks. Let me fill out and go, yeah, these are the best breadsticks ever. It's a very convenient method to get the data, and also produces a little bit of bias towards the data they get. Okay, under coverage is when the way the data was collected, there's particular parts of the population that are left out. Um, things like phone surveys will typically, when you randomly select people from the phone book to answer a particular question, you're missing out on people that don't have phones or people that have hidden their phone number. I don't think anyone uses phone books anymore, but used to be that the really rich people you could pay to have your phone number unlisted, and the really rich people would do that, and the really low income wouldn't even have a phone number, so you'd be missing out on those people with that information. And then it turns out the ones that typically have phone numbers to call would be young adults, mid 20s types. So your data would be reflective of that particular age category and not what the actual population is thinking. Under coverage. Okay, non-response. Non-response occurs when an individual chosen for the sample, either you can't get a hold of them or they just flat out refuse to give you their information. Okay, this is not self-selected, so it's not voluntary response, because non-response means I asked you and you told me no. You refused to participate. Rather, as voluntary response is they chose to give their opinion because they really cared about it. I used to do this. One of my college jobs did telephone surveys, and yeah, I will tell you, you get lots of hangups, lots and lots of hangups. Okay, response bias occurs when the behavior of the respondent or interviewer causes bias in the sample, or you just get flat out wrong answers. People lie, so you're thinking, well, how's that going to work? Well, suppose I went to high school students and I talked about drugs, and I suppose I had a police officer go around and interview students about drug use. Would I get realistic data? Nope. Um, they would lie, or they would misrepresent the information, so I wouldn't be able to trust anything about the data at all in that case. Uh, let's see. Response bias occurs when you actually get incorrect answers. That's going back to the line, or maybe they just don't know the answer. Wording of the question is another one. That's when the way the phrase was worded, it's a little confusing. When they start using words that have different meanings, you want to try to make your verbiage very neutral. You don't want to try to influence one way or the other. Or if they use bigger technical words that maybe the person you're talking to doesn't know, and they're a little nervous to ask. So when you're designing a survey, you want to look at the vocabulary that's being used in the survey. Okay, so say I'm talking to someone just in the middle of nowhere, Texas. I want to avoid the big college words. But in the same sense, if I'm talking to a group of doctors, then I want to use more complex technical wording that they would be used to in order to get a reliable answer. Okay, so here's a couple examples to kind of think through. This one's actually a true story. Before the presidential election of 1936, FDR ran against Alf Landon. A magazine Literary Digest predicted Landon winning by a 3-2 victory. He surveyed 2.8 million people. George Gallup this is the father of statistics, came up with some of the early principles that we use now. Only talked to 50,000 people and accurately predicted that Roosevelt would win. It's the first time that 2.8 million versus 50,000. Nobody thought Gallup knew what he was doing. It turns out he did. The digest surveys came from magazine subscribers, car owners, telephone directories. In other words, people that had money back in 1936, and that wasn't everybody out there, I guess. Anyways, this would be an example of undercoverage, since the digest survey only came from high income. And I guess back in those days, they're mostly Republican. Now, there are other ways to describe this, but this would be the most likely way to describe it. Suppose you want to estimate the total amount of money spent on students by textbooks each semester at college. You collect register receipts for students as they leave the bookstore during lunch one day. What kind of bias could be here? And there's kind of two main ones that stand out. Convenient sampling would be an easy way to collect the data. Or undercoverage, meaning you'd only talk to students at the bookstore. What about the online kids? The method you chose to pick data would not count the online students, and I think nowadays that's a bigger percentage than the ones that go to the physical bookstore. To find the average home in Houston, one averages the price of homes that are listed for sale with a realtor, and that would be under coverage, because they would leave out homes that are not for sale or homes that are listed with different realtors. So you can't really say that the number you get would be representative of the actual average.